This signal is represented by R of t. R of t is equal to AT when t greater than or equal to 0. So 0 I am having, 0 above I am having information, 0 below we don't have any information. So the basic signals all are starts at the initial point only. So like that, if you integrate, if you perform single integration, you will get a R of t signal. Then if you perform again integration for the R of t signal, if R of t is equal to t, if you are integrating this t with respect to dt with the limits 0 to t, again you will get. So for t we are having integration is t square by 2. So 0 to t. If you put limits, we can get t square by t square minus 0 by 2. We will get a t square by 2. So first u of the signal. If you perform single integration, we will get a ramp function. So we can consider, we can call it as signal or function. So signal is information. Function means if you represent a signal in terms of mathematical equations, it is called a function. Okay. So if you perform integration, single integration, we will get R of t. Then you perform again integration for R of t, we will get another signal that is called P of t. That is called P of t means parabolic signal. The signal looks like this one. So parabola shape. Okay. So after that we are having one more important function in total signals and system, that is Dirac delta of t, that is called unit impulse function or unit impulse signal. Actually we don't have impulse signals. Suppose if you consider a pulse signal, some 0 to 1, I am having some pulse signal or some 1 by 2. In between minus 1 by 2 plus 1 by 2, in between this time limit, I am having some pulse signal. The pulse amplitude is 1. So this is the pulse signal. So if you compress this pulse signal, to the 0 level, so it looks like this one. It looks like this one. If you compress this signal. So here I am able to know amplitude and time period, but here I am not able to know what is the exact amplitude of the signal. But I can represent a signal in terms of, I am representing amplitude in terms of 1. Why I am representing 1 means, if you compress signal in 0 level, I am not able to find out the exact height of the signal. But I am able to know area of that signal by using length and width. So here the area is, width is 1 and the length is 1. Here the area is 1. So I am representing here, this 1 is represented area of the signal. Maybe the signal enlarges or compresses. So maybe the time period increases or time period decreases. Maybe amplitude increases, decreases. But the area remains constant. This arrow indicates height of the signal. The height of the signal goes to infinity, but the area of the signal is remain constant. So that's why we are representing unit impulse signal like this. So at 0 only the signal is represented. So at 0 the amplitude of the signal is 1. We can say amplitude, but actually we can say area of the signal. The area of the signal totally represented at t is equal to 0. So if t is not equal to 0, the area should be 0. So this is the very important signal in signals and systems. Thank you.